There are rules to help you determine the amount of sig figs a number or a measurement specifically has. So let's talk about these rules more specifically. The first rule states that all non-zero numbers are significant. What does that really mean? Here's an example. You have 72.3 grams. So none of these are zeros, therefore they're all significant. So there are 3 sig figs in this example. Rule number 2, zeros between non-zero numbers are significant. So in the example here we have 800.4 centimeters. These 2 zeros are between the non-zero numbers of 8 and 4. Therefore all digits here are significant, so we have 4 sig figs. And rule number 3, zeros after the decimal point are significant. So if we look at this example, we have 1.00 seconds. So notice that there are 2 zeros after the decimal point. So therefore that all 3 numbers here are significant in this example. So in rule number 4, we have leading zeros are significant. Leading zeros are insignificant, which means not significant. So in the example here, we have 0.0075 meters. So you have all of these zeros, which are constituted as leading zeros. So therefore, the 7 and the 5, which are non-zero digits, are the only ones that are significant. So 0.0075 meters only has 2 sig figs. And rule number 5, when there's no decimal point present, then the zeros are insignificant as well. So that means when you don't have a decimal point, those zeros are not significant. The example we have here is 10 liters. So there's no decimal point here. So therefore, just the 1 in the 10 liters is significant. So this example has only 1 sig fig. So now we're going to do some practice because you're actually going to have to worry about any type of measurement and whether it has to be precise or accurate and how many sig figs it has. So in order to do that, you are going to be using lab equipment. So here we have our beaker. So our beaker can be read, and doing so, you know this is going to be measured in milliliters. We have a 40 here, we have a 60 here, and our line is actually in between those two. So we're going to say it has 50 milliliters of water, but somebody else may say it's 51, somebody else may say it's really 49. So in order to ensure that everybody's measurement is going to be secure or going to be accurate, we're going to say it's 50 plus or minus 1 milliliter. And that's that one estimated digit that we were talking about before. If you look at number 2, now we have a graduated cylinder. And so in our graduated cylinder, we're at the mark of 35 being down here and 40 being up there. So if this is 35, this is 36. We haven't quite made it to 37 yet. It's really in between 36 and 37. Therefore, we're going to say that this measurement of the graduated cylinder is 36.5. And 0.5 is our digit of estimation. So we're also going to say it's plus or minus 0.1 or a tenth of estimation here, just to make sure that our measurement is going to be correct. Somebody may say it's 36, somebody else may say it's 37. So just to be accurate, we're going to do 36.5 plus or minus 0.1 milliliters. So here, now we're going to actually start applying some of those rules. So in example 3, we have 0.00682. So we want to figure out how many sig figs are in this example. Well, this is rule number 4. You have leading zeros. And when you have leading zeros, those zeros are not significant. So you just count the non-zero numbers, which are 6, 8, and 2. So therefore, in example 3, you have 3 sig figs. So number 4 uses rule number 2, which states that if you have a 0 between non-zero numbers, then that 0 is significant. So therefore, we count all our numbers, 1, 2, 3, 4. We have 4 sig figs in problem 4. And then if you look at example number 5, you have 300 here. So there is no decimal though. So because there's no decimal, only the 3 is going to count as significant, so we'll have 1 sig fig. So good luck. The more you practice, the easier that it will get. We'll use sig figs all semester.